Hey, hello, welcome to the show. It is time for John Park's Workshop. I'm John Park. This is the workshop. We're all here together. Thank you for stopping by. We've got people over in our various chats, so head on over. Just Robert Cochran over in the YouTube chat. Hello, Robert. Over in our Discord chat, which is the place to be if you are somewhere that isn't YouTube. That's it right there. You can go to adafruit.it/discord. I need to clean my glasses. And you will get an instant invite to our Discord server, and then you just want to look for the live broadcast chat channel. That's it, right there. My screen is mirrored. My glasses were filthy. And jump into the conversation. So hello to Starman and David WA90NY and Paul Cutler. Hello. Hey, Andy Calloway. Thank you for popping in. Also joining us over in YouTube chat, Dave Odessa. Hello. Thanks for popping in. Questions from the chats. Let's start with that. Robert says about the Dance Shoes project. I had the cases for both the Sparkle Motion Mini and Power Boost 1000C printed by my local printing service. The case for the Sparkle Motion is a perfect fit. Oh, that's great to hear. I'm glad to hear. What kind of material did you print it in? Is it just a regular PLA or something fancy? I've been meaning to do some of those in PETG. I have PETG material and I have never used it on this current printer. Let's see, over in our YouTube, I'm sorry, in our Discord chat, well, you can see right there. Hello, David says from Washington. Howdy. Lars is tipping his hat. Lars's hat is floating right up over his head there today. So, what we got going on today? I've got a few things for you. We've got a coupon code for the store. I have a recap of the project, or the product pick of the week, excuse me. I have a new CircuitPython Parsec. We've got some continuation of the Knobby Sequencer. I'm calling it Knobby Sequencer Extra Large, XL. You can see right there. Because it's now 16 steps, and I made a case for it that accommodates that. I wanted to show that off to you. I also have a sort of a tooltip, but it's actually a medicine bottle tooltip, a pill bottle. So I'm going to do it right now. I just learned this. Did you know this? Here's a bottle, a typical bottle of Aleve, and it's got a child-proof cap on it, which means that in order to open it, you have to push down on it, and then it grips the cap, and then you can undo it. Makes sense, right? Turns out you can just pop that yellow part off of there and be left with a normal cap, because this has, you hear that? It's got like a little ratchet that has to be engaged by pressing down. You can pop it off the child-proof part And now you're just left with this little svelte cap. You can see the, oh, that's very bright, but if I shade that, you can see there's the little ratchets that get keyed and gripped there. Now it's just a cap. How about that? So if you want to, I don't know, court disaster, don't have any kids in the house, that's an idea. You can just put it back on, like snapping that. I just learned that from a scrolling Instagram. There was a video where someone said, I just learned this. And so hopefully now some of you just learned this. I was very excited about that. It probably isn't going to work on all bottles. Prescription stuff usually is a simpler design than that, squeeze and turn. But for these fancy ones that have the ratcheting, kind of neat. All right, so let's now continue on. Oh, Andy Calloway says they knew that. I have no kids in the house, so I do that. Thumbs up. Let's move on to a coupon code. If you want to go buy some stuff here, this is the Adafruit shop. Let me bring up that page for myself. Right here, you can find some neat stuff. Here's some new products listed right there. I'm excited about this triple LED matrix bonnet. That's pretty cool. You can click on the products drop down, find some categories of things you want, go to new products, click view all, see some stuff you might want, and perhaps you want to save some money on that. Here's how you can do it. Today's coupon code, it is Stretch Armstrong. That's just because I stretched out the knob sequencer design. So Stretch Armstrong. Does everyone remember Stretch Armstrong? I don't know if he's still around. He was a fun stretchy toy filled with weird toxic goo. That right there, if you type in Stretch-Armstrong in the coupon code slot on the way out of the store, you will save 10% on things that we can send to you. It won't work on gift certificates or subscriptions or software, but it will work on physical goods. So save 10% in the Adafruit shop while you're there. If you're thinking of ganging up a bunch of stuff in your order, which I know people do because shipping is expensive, so it makes some sense to gang up a bunch of stuff. Gang up enough to get a free thing if you like. This is how you can do it. If you go to free, adafruit.com/free, you can see the enticements that we have. All you've got to do is spend a certain amount. So at $99 or more, you'll get this free PCB coaster. If you spend $149 or more, you'll get the coaster as well as a KB2040 keyboard. Very cool microcontroller board. And if you spend $199 or more, you will get free UPS ground shipping in the continental US as well as the KB2040 and the coaster. They all stack up. So do that and save some money using that coupon code that you see right there today. It is Stretch Armstrong. Does everyone remember Stretch? Let me see. Can I type that in and get a reasonable result? Stretch Armstrong. Yeah, look. That's Stretch right there. How fun is that? Do they still make Stretch? It was first sold in 1976. That's about when I got mine. Actually, my sister had Stretch. I had the Nemesis dude who was like a green guy. That Stretch Monster? Is that him? Can't remember. Anyway, that's your coupon code for today. Stretch Armstrong will save you 10% in the store and make your limbs longer but thinner. Aaron says in the YouTube chat they had Stretch Monster. Yes. Stretch Monster split open, and I think it had kind of maroon colored goo. I don't think we split open Stretch Armstrong, but Stretch Monster, I expected the goo to be green. It was not. It was kind of maroonish. Okay, so that's your coupon code for today. Stretch Armstrong. Go get some stuff. Next up, let's talk about my Tuesday show, which is the product pick of the week. It looked like that this week, and I'm going to give you a little recap. Check it out. It is big square buttons. These are LED illuminated arcade-style tactile switches.
I'm having trouble understanding right now.
So you can pop this off. You can make your own little fun label. There we go.
No.
I spy cable through there for SPI and I2C. and this is not a perfect fit. So this will still function, in this case as a button. That's the neat thought that Lady Ada had, is these are big enough to fit. This is a 1.54-inch TFT 240-240. We probably have some others that are a little bit of a better fit because they don't have as much PCB. This could make your gigantic version of a keyboard with one display per screen. That's how you would potentially set that up. It is big square button.
No.
Yeah, that's right. That's what it is. Big square button. Go get some. By the way, to continue the conversation from, was it last week, about, I think it was Mouse who asked about the song that I play at the beginning and what was being said in the background of it. This is the song here, you'll hear. So some of that audio was actually sampled off of an Alexa wand, an Amazon Alexa wand. And I played it, I found it, I pitched it and stuff. The other thing I wanted to show you is, you should be able to hear this. One of the reasons it sounds funny like that is granular synthesis, which is a way of chopping up a sample into tiny, tiny little grains. Let me show the down cam here. And let me adjust my focus on that. I just found that sample and engaged a granular version. So instead of just playing the sample,
I'm having trouble understanding now. I'm having trouble understanding right now.
So that was the original sample. If I tell it to not play back as a sample, but play back in granular mode,
I'm having trouble understanding right now.
we can go into a section of it and then play back little tiny chopped up pieces. So that's part of, I also pitched it down a bunch. That's why it sounds the way it sounds, in case you were curious. Let's see. Let's go to, okay, so here's the sample, and then if in granular I want to just focus in on a section. We can tell that to, yeah, trigger is fine. The granular settings are these things like grain size.
I'm having trouble understanding right now.
Scatter will jump around to different little pieces.
I'm having trouble understanding right now.
Little window onto the grains there.
I'm having trouble understanding.
Space them apart.
I'm having trouble understanding right now.
And we can pitch or speed shift.
I'm having trouble understanding right now. I'm having trouble understanding right now.
You get that kind of echo feel. So that was just a little further explanation of what the heck is going on there in the song. Figured since we had the sample out, I could show you that. All right, that is actually a good time for me to fix what I just did to the camera there. Let me try to refocus. That's pretty good. Because it is actually time for the CircuitPython Parsec. Okay, for the CircuitPython Parsec today, I would like to talk about using an indexed color from a palette to create transparency. So what you can see here, I have an image up inside of Sprite, which is a little pixel editing, image editing software. It's this image of Adabot on this pink background. And in the left window, you can see the palette of colors that I'm using here. So the second color, this is indexed 0, so we'll call that number 1. Color number 1 is this pink background. When I have a sprite in Display I/O and I want to show it in front of something else but cut out portions of it or make portions of it transparent, I can use the make transparent command and then tell it one of the index colors from that color palette. So if I run this program, you'll see I'm creating a little background that has sort of a yellow-green and then a bunch of circles on it. And then I have the same Adabot BMP that you see there, but I'm selectively telling it to make color number 1 transparent, so that pink is disappearing. Now we can pick other colors if we want. So if we look at, I think it's color 1, 2, 3, 4, 5. Oh, let me move the palette so I can see it. I think color 3 is the blue of Adabot's head, or 0, 1, 2 will be the color number. So if I look in my code here for a transparency index, I can change that, what did I say, to number 3 and resave. And now we're going to selectively make Adabot's head transparent, leaving the, oh, it's actually the chest part there. So let's try some others. So you can see which blue I used. Is that it? There we go. And also one of the antennae. So the way this is done in CircuitPython, and let me resave this as color 1 as that's going. Okay, is I'm going to import all of the display things I need. This happens to be a display using SPI, a little TFT display. It's 320 by 240. Create the display, grab an image off of disk, which is this BMP of Adabot. And then I'm going to create the background as a bitmap. I'm also going to create a bunch of circles. So I have a little randomizing script here, grabbing from a few different colors with a few sizes. So we put about 40 circles up on the screen. Create those as vector IO circles. And then I'm going to grab this image off of disk, which happens to be adabot1.bmp, and I'm going to grab the image and the palette from the file through the file load. Then I can call the palette here as screen2, it's the second or third object, pixel shader. So once we have that pixel shader grabbed, we can make a palette for it. So my transparent index number here, 1, I'm going to say display the image, so we load that right up away. But then in the main loop, as we're cycling through that, we wait, speed, I have 1.6 seconds of hold, and then I say from that palette, right there you can see that palette that we grabbed off of that particular image object, from that palette we're going to make transparent one of the colors. In this case it is color 1 based on this transparent index. Then I wait another 1.5 seconds or so and make it opaque. So you can use the make transparent and the make opaque. Now, one of the neat things is that you don't have to be limited to just a single color. So in this case, I'm going to make both the background and the face disappear by saying the index and index plus 1, which just happens to be the next color is the blue that's used in Adabot's face. And so you can use this for every color in your index or use it selectively, but you can see it works really nicely. It's great for effects in games and things, and you don't have to have a bunch of different images. You don't have to do any sort of real-time processing. You can just simply say, knock out this color, and we're going to see what's behind it. And so that is how you can use a transparent index color from a palette of a BMP inside of CircuitPython. And that is your CircuitPython Parsec. All right, audio back on. So let me unplug that there. This, by the way, I can hold it up here. I don't have a battery on it, but this is a Feather with a Feather TFT feather wing, and that is the 2.4 inch, I believe, TFT feather wing. Nice display, easy to work with. I've used it for a bunch of projects. There's a nice case that the Ruiz brothers made for a weather station project that I have it all inside of. But that inside of there is just the, I'll show it. Right inside of there is Feather RP2040 in this case, plugged right into the feather wing, the TFT feather wing. Click that back together. We got a little spot there for the USB-C, and I also have a little hole there for running a STEMMA QT cable for external stuff, which I wasn't using in this example. All right, let's see. Next up, let's get into this build of the sequencer, the Knobby sequencer, which is now 16 steps. So I'm going to jump over here to the workbench. You can see I've got my pieces and parts. I've already soldered it all up. We'll just do some assembly today and a quick bit of testing. So let's put a bench cam there, and I'm going to head over. I'll grab my coffee cup on the way. which sadly is almost empty. Okay, so what you can see here, I've just been transporting the parts around inside of this little box. Coffee down over here, away from things so I don't dump any. So I've now got, let me see if I can boost the, no, not on this one. Oh geez, I keep forgetting. Let's see if I can bring that lighting up a little bit. There we go. So now I've got a 16 knob front plate, a little diffuser here, and then the bottom plate. And I'm going to get these out of the way for a second. What the circuit is comprised of is just double of everything from last week. So I've got QT Py right here. Zoom in a little bit. And then over stemma QT, we're running to 4 instead of 2 of these quad rotary encoder breakouts that use seesaw. I ran out of the shorter cables there, so I have to tuck that in there. But there are now 16 encoders, push encoders. If you remember, or if you haven't seen the previous parts of this build, I'm not using the little LEDs underneath because I don't have clear shaft encoders, and also these are a little slow since they're messaged over I2C compared to regular NeoPixels that are just running to one of the pins on my QT Py. So I've got 4 of these encoders, and then I have 6 of these little NeoPixel strip boards that each have 8 NeoPixels in them. I paused there because I remembered I had, when I had been testing this, I wasn't too worried about getting these close together. We may not be able to fit these 2 next to each other because I temporarily had wiring between these and didn't use my little header pins as connectors because these are separate boards. You can see where they're soldered there. So this might be a little underneath one to get it lined up to the screw holes. But those happen to have every 3rd NeoPixel spacing with the encoder knobs. That works pretty well, works out pretty well. We can get light that one, dark, dark, light that one. Get this centered here. Dark, dark, light, dark, dark, light. So those give us a nice display, and that's what I'm shining up through this little diffuser here with this top plate. So to assemble these, I've got a bunch of M2.5 hardware, as well as we're going to use some of these little, I think they're 1/4 inch or a little smaller, shaft nuts that go over the encoders to click that onto the top there. But we'll start with the bottom of this. And so the way this is designed, I've got the little QT Py. You can see some holes through there. I've got the little QT Py holder that will go like this onto there, I believe, yeah. And then on the upper holes set there, we're going to plug in these standoffs, these little M2.5 standoffs. So let's start with, I'm just going to use 2 screws on most of this so it goes a little faster, but we'll start with these. And I'm hoping actually this video may also serve as a useful guide for assembly along with the photos that I put in the Learn Guide. So we'll do, obviously I'm not showing the soldering portion of this, and I'm just going to hand tighten these. But this is a nice little QT Py mount that the Reeves brothers make. We sell them in the store. You can also just download the file and print it yourself. I'm using one of these SLA printed ones. They're quite nice. And there we go. The next step here is going to be, you can see this one sits right above, like so. So right above the QT Py. I'm going to change my focus a little bit here. There we go. Right above the cutie pie, but we can still access. Oh wait, did I get this flipped? I got this flipped. I want that. Well, do I mind that? Is that so bad? I think I mind that. Yeah, this I have this flipped upside down. Let's do that right. I originally intended to laser cut these parts, but my laser cutter's tube is almost end of life. I can barely get a couple cuts out of it before it just doesn't provide any more lasing. So last time I replaced it was about 7 years ago, so I think I'm due for a replacement. But right now I am instead using the 3D printer for something that the laser cutter would make in about 5 minutes instead of 3D printing it in about an hour. These also, by the way, stretch the limits of what I can print. I have a Bamboo Labs 3D printer, and I had to print these diagonally to fit. Doesn't fit on the camera. Let me zoom out a little. So I had to go diagonally to fit because it's actually wider than the bed. I think the bed is 275 millimeters, something like that. All right, so there we go. That through there. You can, in fact, I think you can tell that I printed it diagonally because if you look at these fill lines on the first layer, those are usually diagonal at 45 degrees. So you can see I pretty much had a 45-degree angle on the part, and so it looks like it has vertical lines, which is kind of an interesting little hack for if you can't change that directionality, but you want sort of vertical lines. It's probably not as strong this way as diagonal, but there we have it. Okay, so now that's more what I wanted. That's going to put the USB port right at the back of the thing. So now we'll plug in. I've got M2.5, I think, by 10 or 8 millimeter. And I can go for a smaller screw here. Screw that up from the bottom there. And let me grab a screwdriver. So these should, I should be able to go there with the wiring I have. Slip that to that side. And let's get another screw in here. 2 by 2 on these instead of 4 per board is probably fine for this connection, since we're connected to the top through the shaft screws. Oh geez, Andy Calloway says I need a printer like Ivan Miranda's. He's printed a full-size canoe. I think I'm out of space for that size of a printer. That's wild. Okay, so now we'll just put the other 3 of these on. And I talked about this last week, but essentially I was able to bring in the CAD files that the Ruiz brothers made for these quad rotary encoder boards and get nice precise measurements off of them. Drew a little rectangle and created a little workflow in Rhino using Grasshopper to parametrically build this. Updating it to, I didn't design it to be parametric in the sense of giving a user slider for width or anything like that, but it was very simple to just double the width of the thing and double the instances of the holes. So it didn't take much work to move this from 8 to 16 encoders. And the code was pretty straightforward to update as well. These encoders have, I don't know what the total is. If someone wants to look and do the math, but we've got one I2C address, I think it's 49 by default. And then if you cut the first jumper, it goes to 4A. the second for B, the first and the second for C, the third for D, and so on. So yeah, you might be able to use like 16 of these or something like that for a really big sequencer, depending on your needs. You probably don't want to keep going. Right now it's about the width of my computer keyboard, which is a kind of nice shape. Any more than this and you probably want to start going in rows. But I'll demonstrate, once I get this put together, I'll demonstrate to you that it's quite a difference going to having a sequence of 16 notes versus 8. It's a little more interesting, not quite as repetitive. Of course, we could adjust things in code so that we have pages of sequences that we're scrolling through, but I'm keeping it pretty simple for now. Okay, one more and we're done screwing in encoder boards. There we are. This would be a good time to test this thing. I'm just going to give it power just to see if things are largely connected. It doesn't need, oh look, I just broke a connection to the NeoPixels by manhandling it, so those won't light up, but we should still be able to just give this some power and see the lights under the boards light up. So I can see I've got little green power lights under there. Can you see those? You might be able to. There's one right there. So I'm seeing power on that. That's good. We'll have to fix the wiring that I just decimated. Let's come in real close. Let's fire up a soldering iron. Not what I was expecting to be doing here. There's power. That's a good supply. I need a nice thick cable for that one. Hopefully this, I don't know where the correct one went, so let's see. This complains or if it gives us power. Heating. Let's see if it gets up to 300. Sensor error. Yeah, I think that I need to find a good thick, where is the proper cable for that? I hope I didn't steal it and bring it inside. Oh, this one looks good. Let's see if this one does it. I think this will. Oh no, that's micro B. That won't do it. Drat. Not you. That's the old boxy style one. I should not be allowed to move USB cables around. This is a short cable. Let's see if it's a little better. I think what's happening is there's just too much resistance on this to provide the soldering iron the power it wants. Heating. Sensor error. Okay. I think I may have a backup of a little portable soldering iron. Otherwise, we'll be out of luck and we'll do this without the NeoPixels on it. One other thing. I'm just going to see if I plug closer to the source. I just have a bunch of resistance. Todd said, blows my mind that soldering irons now have CPUs and displays on them. Yeah, it's pretty wild. Sensor error still. No, drat. Okay. I think I'm out of luck on that iron. So we'll just not have NeoPixels. I'll still put the build together here, so we can see that. Is there any chance? I don't think I have a fine enough tip for my reflow right now, but I'm wondering if I could heat that up enough. Let me just check one other place for that cable. If anyone knows if that sensor error on this device is something other than what I'm thinking it is, let me know. Where did I just put? Did I just lose the soldering iron? I set it down over here. There it is. I feel like I've used this cable before. What if I leave it alone and stop pressing that one button? You just set it here, not touching anything. Heating. Yeah, I think it's unhappy. This might just be like a firmware-y kind of thing, though. Restore default, sure. Tip. Okay, are you getting hot? Grab some solder. Is it actually just heating anyway? Nope. Sorry, I was not showing you the iron, so you're staring at nothing there. I think it's just kind of glitching. I don't know if it's the power or something else. The soldering iron has crashed. Leave that alone. Where did I put that little Hakko portable iron? Tell me that. Is it in here? Well, lesson learned. I should have a backup soldering iron in here for the show. Rats. How's it doing now? STB temp? What does that mean? Are you at all warm? No. Power 18. Temp stop off volt. Temp C. Yeah, Andy Callaway, you just plug yours into the mains, and I missed that. I liked how this one was sort of small and convenient, but not when I have to face this. Restore default. I'm going to hold this. Did that restore default? Heating. Yeah, no, I think it's really glitched out. Send error. That's like the accelerometer for... Yeah. John Nodge says, I was about to ask about the Hakko portable. It's great, except where is it? I may have put it into a little toolbox or go bag. All right, well, I will give, this is possibly going to be disastrous, but I'll give my little rework iron a shot here. This will probably melt everything. Let's find out. So how about low air, high temp? let's see if this has what it takes. Let me get. Well, we may end up charring the workbench a little here too. Let me just see if I can tin. Okay, that tinned. Hey, this might just work. Are you seeing this? Let me move some things into view here. So I just tinned that piece of wire there. You can see. Can I get closer? No. Let me grab some tweezers. Oh, good. My hot air gun doesn't reach. Let's move this where it reaches to. Yeah, I'm charring up the workbench. Very cool. Let me twist the camera a little there. And what do I have that I can put down? Well, let's just be quick. How about? So I'm going to try to okay. I think I just soldered it. That was very MacGyver-y. Let's try this out. All right, unplugging the dead little pencil solderer, which I think I'm now going to be mad at. Got to be a little cautious about that joint there. I don't want to rip that off again, but if we're careful, should be able now to power this up and see some LEDs. Let me zoom out. It's actually I've got quite a lot of light on here, so we may or may not see the LEDs at the moment, but let's go ahead and give this some power. I'm just going to go off of a battery because it's handy. That one's dead. All right, we'll go off of this USB. Yay, we have LEDs. Let me turn this off so you can actually see them. There you go. A little dim there. They're quite bright in real life, so I've actually dimmed these in code. So you can see here, these will allow us to use the 16 encoders to mute and unmute steps. That's not quite aligned at the moment. And adjust their notes values. I've also added some gradation stuff, so when a note is low, it's yellowish, like that one right there. Probably see. Let me put my little diffuser on top. Yeah, it's a little hard to see on camera too, but it's green when it's a high note and it's yellow when it's a low. Just a little bit of guidance on that one's green. These two around it are yellow. It works well in real life. You could make that a little more extreme for putting on camera. Okay, so that's good. Let me pull this light back into the picture. I'm going to take power off of there, and now we will carefully and gingerly attach these to this. So I think this should work with this orientation. Might need a little finagling there to pop those in, but there we go. Before I pop those on there, though, we want to screw in the NeoPixel strips. And to do that without breaking the little emergency repair soldering job there, I'm going to thread just a couple longer screws through the top, and then there's a receiving hole on the pixel strip. Screw that in, and then I'll put a nut on the other side of that. I also had a little electric screwdriver at one point, and that too died. So I have not to disparage those things, but I'm having some issues with these microcontroller bearing tools, like soldering irons and screwdrivers. Okay. This, by the way, I believe last time I reversed this order of operations, and I'm wishing I had this time. Screw the NeoPixels into the top plate before getting that QT Py locked in place there. Okay, I'll just put a nut on the back of that. John Nodge says in the chat, who's laying odds for another impromptu soldering session? I sure hope not. One is enough. More than that, it is pushing your luck. Okay. Not maybe a bad idea in a case like this to use some little JST through-wire connectors, but that also kind of adds to the bulk. I'm trying to keep this svelte. All right, so here's the case where since I had done these modularly and I didn't account for these actually butting up next to each other, this one's not really going to fit there. So I think I may just leave that. Let's see if that, yeah, I think I might be able to leave that farther below, but it may bump into this. I think I'll leave that dangling. I think that one's not going to go right now. Okay, so now if we can get that to there, before I screw anything down, I'm going to give it power again to see if our NeoPixel strips are still alive. Yay! So you can see that there. The diffuser actually kind of helps with the... I've got a couple of orientations of it to try. I like that one. Wow, wow. Okay, good. Take the power off. And then I'm going to press this down onto encoders. Being a little ginger because I don't want to cause any more trouble for that NeoPixel wire. Will this one fit? Ah, you know what? So one of the things I think I can just turn that nut a little bit. One of the things I did to get it to print was I had to make it a little less deep this way so that on the 45 it wouldn't hang off. So I shrunk some things a little closer to each other. And now, there we go. It's just a tighter fit, but yeah, that's good. That works. Nice. Yeah. Okay. Good. So this one, just imagine, will be in there. We could set it way lower with some screws, but I think I'm just going to leave it dangling. And then we can use a few, I'm not going to do them all, but we can use a few of these nuts to screw the encoder shafts to the plate. I believe the 10mm socket, which I have a few of, works on these, although no, maybe they're a little smaller than that. These might be the 9s. That's enough of these for this use. The part that I won't skimp on is knobs. So again, I've got this nice Roland 808 scheme going of red, orange, yellow, and white or cream. Wow, last one. And if you were watching last week, you saw I had one issue where the flat that's built onto this shaft is quite deep. Deep enough that some of these little set screws in the knobs won't bite into it without going through too far and then kind of wobbling around. I realized I don't really need to use that flat at all. I can go anywhere on the round part of the shaft, then lift it up about 1/4 inch or less because of the push encoder button there, and then tighten that up. So I'm not bothering with the flat, and that bites into it nicely. So that's my new strategy, is to not worry about the way they intended you to use it, but instead use it the way that's going to work. And since these are not potentiometers, they can go on any way we want. There's not a correct direction. In fact, these knobs shouldn't even have pointers on them because it's an endless encoder, but it's what I've got. If that really bothered you, you could probably sand those off, or file those out, or paint them, or do something like that. There we go. Let's see, does it work? So I'm just going to turn all of these so that I get to the fleshy round part. There we are. All right. Todd in the chat has me growing a mullet. What's up with that? What do I need a mullet for? Explain yourself. All right, there we go. These encoders, by the way, if you get the little encoder plus extras sets on Adafruit, they come with a knob that just slides on, sort of more traditional plastic D-shaft knobs. You don't have to get these extra fancy colored knobs. That's just a nice to have. I do actually like this color scheme breaking up the bars. So red is the first beat of every measure. Yellow is the third. So if you're setting down a pattern, you know, just looking at them without having to count or anything like that. Otherwise, if they're all identical, it actually can be a little bit of work to see at a glance where the first note is on the third bar. Here I can see it, it's red. Yeah, do you like this? Now I've got this permanent record of my impatiently, that's the char, impatiently using a hot air gun without setting down a piece of metal there first. Don't do it the way I did it. Do it the right way. That was the impatient way. Almost there. And now we can go plug it in over in my black box over there. Okay, so pretend this is in there. I'm going to set my little diffuser down. And let's look at that, huh? Looking cool, looking very cool. All right, so I'm gonna click on over here. Let me zoom out and hope that that camera doesn't flop over, because that's a very precarious, slightly broken camera arm now. Everything's falling apart here in John Park's workshop. Okay, let's boost that exposure a bit. And let me tune the white balance, which is kind of crazy. That's a little more natural. So, stealing back the cable that failed to run the soldering iron. I'm going to plug sequencer into black box, which I'm just going to make sure I'm not sending MIDI notes to that. I'm not. Let's go to this sample. I think I am, which is good. Okay, so black box will host the CircuitPy. CircuitPy just runs. I don't have any start stop. It's not listening to anything external. It's just going to start playing note on offs. Okay, should be able to hear that. Let me know in the chat. And let's go. All right, so that's the notes. Let me explain some things here. That's the notes before getting kind of generally repitched. So I'm just setting it at the default. And I'm going to give it a little bit of a cutoff instead of a trigger. Okay, it's on gate. That's good. So let's... I'm going to make it a little pluckier. Okay, cool. Now we can go and move that under there. Start turning off notes. So now you can see I get a lot more variety with 8 versus 16. Stop that for a second. And so this is running on a scale. If we take a look at my code editor, let me hide some stuff. Let's get this out of here. Whoa, no, I want you. I just don't want you right there. And I will... find the latest version of that code. This might, I don't have the CircuitPy plugged in, so I'm just going to grab it off of my server. Yeah, this is a 16-step version. It may not be the latest, but so you can see I've made it configurable for 1, 2, 3, or 4 of these little quad encoders, and we could extend that too. And so 4, 8, 12, or 16 steps. So for example, let me come down to steps. It's set to 16. If I set this just to 4, hit save. Oh, I don't have it plugged in. Never mind that. Yeah, let's not do that because then we won't be able to play samples from it. If I save with that, then it's just going to instantiate the first board. And so I have all 4 boards I2C addresses here, so 49, 4A, 4B, 4C. Those are the 4 addresses of 4 consecutive boards. You could extend this, but I'm just going to leave it with these options in here. Tempo, some nice I've just got it in code right now. So BPM right here, we can set that to a different tempo. I'm laughing because Todd says, yeah, you buy different sequencers for different tempos. Yeah, hold on, let me get my 90 BPM sequencer. The thing I'm struggling with is I don't want to complicate the interface. I like just having a knob per function for this. I don't want to have a screen on it. How would you adjust something like tempo? Possibly on startup. I mentioned this last week. I think one idea I had is just when it starts up, it gives you a series of LED colored based prompts. Like the first one, in this first section, you set your tempo. The next one, you set your key that you're in, the scales that you're in. So those are some possible ways to do that, but I'd be curious. Yeah, LEDs. Okay, you're on. Hey, Steve. So keeping it minimal does have its issues. I've done this sort of thing before with that modal MIDI keyboard where on start it doesn't get going until you answer some questions, until you do some user input. So let's see. Yeah, that's the main adjustment. And then also, I think since last week, a change I made was I took the whole scales and popped them out into a separate file. So I just put a reminder to myself in the comments of this code of which scales I have in there. If you remember, I worked with Claude to come up with a whole slew of scales. And now I have them running like 7 octaves worth or something like that by extrapolating out from one measure or one octave. So I can type in, you know, Lydian down here in scale instead of major, and it's going to play from that scale. Those live, I didn't want to keep looking at all that, so those live up in the separate file, scales.py, and so you can see we just get a single octave's worth of each of these scales, and then the main runtime code can populate those with the full like 6 or 7 octaves. So that's roughly how that's working right now. And yeah, other than I need to fix how I'm soldering up this last section here to get that up there. But actually you can see we do still get, even from very far away, it works pretty well with that little diffuser to show the steps. There. All right. Somebody says, it sounds like a teenage engineering product when Todd quips. So you've got the 131 BPM version in matte green. Ooh, very bespoke. Quinman16 asked, did you buy all new knobs? Yeah, I'll show you what I'm using in there. The products at play are the quad rotary encoder right there. In fact, in the demo, you can see we've got some of those lovely Davies style clone knobs on there, so they're probably linked down below. Multicolor micro potentiometer knob, rainbow 10-pack. That'll give you one of each of those, or I bought, these actually happen to come in 4-packs. So pack of red, pack of orange, pack of yellow, pack of cream, that's what I'm using, and then QT-Py RP2040, and the NeoPixel sticks. NeoPixel stick. These right here. That's it, other than some hardware, the encoders, of course. A bunch of these guys, rotary encoders plus extras. And wire. I think that's it. So I'll be putting that guide together. I'll commit the code. I meant to last night but got busy, but I'm going to commit the code later today. And then we can maybe refine that if we come up with other ideas for entering BPM and things like that. Another possibility could be trying to use double clicks to say, hey, I'm going to switch the function of this knob temporarily, change maybe one of the neopixels to the sides of it to go purple and say, okay, you're in BPM mode now, and then double click to get back to regular mode. That might be a nice way to do it, but for now, I'm just typing it in code. All right. Oh, and someone made a suggestion. Maybe double press the first knob sets an alternative. Oh, John Nodge and I just had, I think, the same exact idea at the same time. Or I read that subconsciously. Excellent. Yeah, I love that. All right, that's the way. We'll do that. Double click to get into your different functions. Maybe all the knobs then can have a separate function when we're in that mode. Cool. All right. That is the project. That's what I'm working on. Reminder, if you want to go get any of that stuff, such as knobs and rotary encoders and so forth, or brand new products, this is your coupon code for the day, Stretch Armstrong. That will get you 10% off in the store. So just remember to type that in when you get there in the coupon code slot. I believe Foamy Guy will be doing a deep dive this weekend, but he may be off tomorrow due to the holiday. So happy 4th of July to people who celebrate that. Look, there is Stretch Lars Strong. Nicely done, Andy. The following videos may be Lady Ada videos during the Desk of Lady Ada videos during the weekend, followed by Product Pick of the Week on Tuesday, Show and Tell. I'm sorry, 3D Hangouts on Wednesday morning, Show and Tell in the evening, and Ask an Engineer after that. So just stay tuned to the blog and to our Discord to see what is going on. Thanks everyone for coming and hanging out with me and for seeing some MacGyvering of soldering duties there. I promise I will clean up in here and swap out the soldering iron. For Adafruit Industries, I'm John Park, and this has been John Park's Workshop. I will see you soon. Bye-bye.
Thank you.